Hello, mathletes. So we're in chapter 6 now, which is inverses and radical functions, inverse functions and radical functions. So we're going to start with operations on functions in this first lesson today. And this may have been, you may have seen this before. Anyway, we're going to do all the basic 4 operations with functions. We're going to add, subtract, multiply, divide. The main thing is just understanding the notation. So when I say f plus g of x in this format, that just means I'm going to add the f of x function plus the g of x function, right? Same thing with subtraction. F minus g of x means f of x minus g of x. And then if I multiply, if I have f times g of x, or f times g of x in that sense, then it would be f of x times g of x. Sometimes you'll see a little dot in here too, right, between the f and the g. So it could be either way. They could be just next to each other, or they could be have a multiplication symbol between them. All right, and then f divided by g of x is just f of x divided by g of x, or f of x over g of x. And g of x cannot be 0, right, because we cannot divide by 0. So that stipulation has to be stated there. All right, so just kind of knowing this notation is the important thing. Sometimes you'll just see it like this, you know, on this side here. Sometimes they'll just show it like this, which is a little more self-explanatory. But this way is maybe a little more succinct or compact. So that way is used a lot of times as well. All right, then the next, the other thing we'll do is composition of functions. So composition of functions, where you combine functions together. You basically put one, you input a function into another function. So the domain of the function, instead of being x, becomes a whole nother function like g of x in this case, right? So now the input is g of x, and the output is whatever you get, you know, from that. Okay. So, and sometimes you'll see it like this, where you have this open circle here. Sometimes people call that fog of x, kind of informally, but the way you say this is you say f composition g, or you say f of g of x. Okay, so that's the way you say that, and we'll come to, when we get to those, we'll talk a little more about it. All right, I'll just write it here, f of g of x. Okay, and it's kind of like this, right? F of g of x. So, or you can say the composition of f and g. All right, so let's see some examples. So here we're looking to operate, right? So we have all these operations. So we want to do those for each f of x and g of x. So, so for number 1, let's start by adding. So I want to add, so f plus g of x is going to be just f of x plus g of x, right? So it's going to be f of x, which is 3x plus 1, plus g of x, right, which is 2x minus 3. So we just combine like terms, and so we end up with 5x minus 2. All right, so then next let's do f of x minus g of x. So f of g of f minus g of x equals f of x minus g of x. So we're going to take the first function, f of x, 3x plus 1, and subtract the second function, 2x minus 3. Now in the first one we didn't need parentheses, because whenever we're just adding two things and we don't have anything we're multiplying or anything like that, we can just add them. But here we're subtracting this whole function g of x. So we have to put g of x in parentheses, because this negative applies to the whole function, not just the 2x. So we're going to distribute the negative, and so we'll end up with 3x plus 1 minus 2x plus 3. And so then that'll turn into 1x plus 4. Okay. So that's f minus g of x. All right, next we'll multiply f times g of x, right? So that's this one here. So that's going to equal 3x plus 1 multiplied by 2x minus 3. So now we just FOIL, right? We've done this before. So none of these operations are really new. It's more just the notation that's new. 6x squared, 3x times negative 3 is negative 9x. 1 times 2x is 2x, and 1 times negative 3 is negative 3. And so when we simplify that, we'll get 6x squared minus 7x minus 3. All right. Okay, let me draw lines between these here. So that one. All right, and then the last one we're going to divide. So this one, we're going to do f over g of x, right? F divided by g of x. So all we're going to do here is just put one function over the other. So we're going to put f of x, 3x plus 1, over the other one, 2x minus 3. All right, and we can see here there's no common factors, right? And so there's nothing we can do with that, nothing to simplify. So we just leave it like it is. All right, let's do this number 2 here. So first, we'll find f plus g of x. All right, which is 3x squared plus 5 over x. And there's really nothing we can do with that. We could get a common denominator here, multiply by, put this over 1, multiply by x on top and bottom, and go from there. But we're going to learn that a little bit later in the next chapter. Actually, we're going to talk about rational expressions and functions and things like that. So we're not going to deal with that right now. So we can just leave it like it is. Now, one thing to note is this is not a polynomial function anymore, right? So going back to kind of what we talked about in the last lesson, remember polynomial functions only have, or in the last chapter, polynomial functions only have positive exponents, and 5 over x can be written as 5x to the negative 1. So that's a negative exponent, right? And so, so anyway, this becomes a different type of function. Same with this one here, right? All the other ones are polynomials, but that one we have an x in the bottom, and so that turns it into a rational function, which has a different behavior than a polynomial. All right. Okay, so next I'm going to do f minus g of x. So it's just going to be 3x squared minus 5 over x. And same thing, right? We can't really simplify that, so we just leave it as is. Okay, then we have f times g of x. So we're going to multiply these together, 3x squared multiplied by 5 over x. And then what happens is this is over 1, right? The x and the x, one of the x's and the x squared cancel out, so we end up with 1x. So x to the first. And so we have 3x to the first times 5. So 3 times 5 is 15. And then x to the first I can just write as x. All right, and then last but not least, we're going to do our division. So f divided by g of x is going to be 3x squared over 5 over x, right? And this is actually what's called a complex fraction, when you have a fraction within another fraction. And there's another thing we're going to discuss with more detail in the next chapter. But remember, we know whenever we divide fractions, what we do is we take the numerator fraction and multiply it by the reciprocal of the denominator fraction, right? So we flip that guy and multiply. And so 3x squared times x is 3x cubed. And then on the bottom, 1 times 5 is 5. That's as far as we can simplify. All right. So not too bad. Really nothing we haven't done before except for the notation, I think, is new. You know, just knowing what all these different things mean, right? Knowing what all these different expressions now. All right. Let me know if you have any questions, and we'll talk about composition of functions next.